Quadratic expressions. Basically, these are going to be more complicated trig substitution problems. Recall on the trig substitution, we were dealing with things a squared plus x squared minus x squared minus a squared, and we set up the triangles. We don't have that form right here, but since we have our algebraic skills, we can create it. So when we're looking at this, we could say, how can I make this a perfect square? If I did something like 16 minus 16 plus 8x minus x squared, and that's all going to be underneath our radical. Why is that good? Note 16 minus 16 is just 0, so I haven't actually changed the value of this. But now I can factor this out to say that this is x squared minus 8x plus 16. Now I have a perfect square. So when I set up this integral, or when I do this next part, this will be 4 squared minus x minus 4 quantity squared dx. And at this point, we can go through it exactly the way we did our trig substitution stuff before. So we had set up our triangle. We have theta. We want to put, well, we have to put 4 on the hypotenuse. We want x minus 4 on the vertical leg. Now we'll have something that goes with this, not just a plain x. It'll be either an expression, a binomial, and we'll still have our radical on the lower part. So we'll have 4 squared minus x minus 4 quantity squared. So we'll define our trig function. We want sine. Sine theta will equal x minus 4 over 4. And then, so that'd be 4 sine theta equals x minus 4. If we take find the differential, dx, we'll have 4 cosine theta d theta. We need the expression for the radical on the bottom, and that would be 4 cosine theta would equal that radical, 4 squared minus that quantity x minus 4 quantity squared, and that's the same thing as we have right there. So when we do our substitution in, we have 1, that's just a 1. The dx will be 4 cosine of theta d theta divided by 4 cosine theta. So we have the integral of d theta, which is just theta plus c. What is theta? We have sine theta is x minus 4 over 4. So we have the the inverse of that. So it's the inverse sine of x minus 4 over 4 plus c. Let's take a look at the next one. We want to make a perfect square here. That's our goal. So really the focus, we could ignore the 10 here. And what you would have done back in Algebra 2 is divide this thing by the 4, so you could have a coefficient of 1 for the x squared. For these kind of problems, that's not the best idea. What we really want to do is just leave that there. So we know it's going to be 4x squared minus 4x plus something, and then we'll have our 10 over here. So what would this be? Well, we know if this is going to be a perfect square, it would have to be 2x something squared. Now, we're going to have a negative 4 here, so this has to be 2 times 2x times what will give us the negative 4? Times negative 1. This will be plus 1. And then what we could do is either say minus 1, or I could have taken this 10 and broken that up into just the 9 right away. So I can write it as 1 over 2x minus 1 squared plus 9 dx. And now both this last one and this one are pretty straightforward ones in terms of doing a trig substitution And there's other ways that you could do it. We could do a regular substitution and put it into the form to recognize, but right now I just want to focus on that trig substitution idea. So I'll set up my triangle. My vertical leg is going to be 2x minus 1. My horizontal will be 3. This will be the square root of 2x minus 1 squared plus 9. Now I can start doing my substitution part. Here's my theta. So tangent theta, 3 tan theta equals 2x minus 1. If we take the derivative of that, or differential, we'll have 3 secant squared theta d theta equals 2 dx. We want to move that 2 to the other side, so we have 3 halves secant squared d theta equals dx. We also need to get the expression for the square root there. I don't quite have enough room there, so I'll do it down here. We'll have 3 secant theta equals the square root of 2x minus 1 quantity squared plus 9. Just write that properly. So square both sides. 9 secant squared equals 2x minus 1 squared plus 9. Make our substitution in. And we'll have on the top 3 halves secant squared theta d theta. That's coming from here. That's our dx. And on the bottom, we have the 9 secant squared theta. Reduce that fraction, we get 1/6 the integral of d theta. So it's 1/6 theta plus c. What is theta? Theta will be we have tan theta equals 2x minus 1 over 3. So then theta will be the inverse tangent of 2x minus 1 over 3. And then tack on our plus c. And that's it for those two. So those two are pretty straightforward, not too bad.